Okay, we're going to be taking a look at exponent laws today. So here's the three basic exponent laws, all right? When you're taking a look at an exponent, exponent is composed of two characteristics. You have a base, which we'll denote in this case as an x, and then you have the exponent, which in some cases you can put an n for exponent. So this is what they call like exponential notation. It has a base, in this case it's x, an exponent, some power, in this case an n. Okay, so how do we apply this to our exponent rules? Well, if you notice here, we're multiplying, right? This operation here indicates multiplication. We're multiplying with the same base. When you multiply with the same base, you add the exponents, right? So x to the a times x to the b would be x to the a plus b. As a little example here with some numbers, let's say you had 2 to the power 3 times 2 to the power 5. Now we're multiplying with the same base. You add the exponents, in which case this becomes 2 to the power of 8. Likewise, that base does not have to be and just an integer. You could have something like 2 to the power 2/3 to the power of 2 times 2/3 to the power of 3. And again, that base now is not 2. The base is the entire fraction, in this case 2/3. This would be 2/3 to the power of 5. Okay, let's take a look at exponent law 2. So exponent law 2, you're dividing with the same base. When you're dividing with the same base, you subtract the exponents. So in this case here, x to the a divided by x to the b would be x to the a minus b. Again, looking at a little example here, let's see how that would look with some numbers. Let's say you have 5 to the power of 4 divided by 5 to the power of 2. Now we're dividing with the same base. It would be 5 to the power of 4 minus 2, or just 5 to the power of 2. And likewise here, you can do the exact same thing with fractions. If I have 2/3 to the power of 10 divided by 2/3 to the power of 8, you're dividing with the same base, and in which case you subtract those exponents, and that gives you 2/3 to the power of 2. Okay, let's take a look at our final exponent law here. Now in this situation here, you have x to the power of a to the power of b. So now this is like power to a power. And whenever you have power to a power, you actually multiply those out. This becomes x to the power of a times b. If we look at a little example here, say for example here, 2 to the power of 3 raised to the power of 4, that would be 2 to the power of 2 times 3 is 12. Likewise, if you have 2/3 to the power of 2 and that whole thing raised to the power of 10, this would be equal to 2/3 to the power of 20. Okay, so these are our basic exponent laws here. Let's take a look at some word problems, kind of going through some other examples. Okay, so example 1 here, if you take a look, there's a lot going on in this question, but if you take a look here, your BEDMAS rules still apply. You want to take a look at brackets, see if there's anything to do inside of them. I don't have anything going on in the brackets. However, I want to apply my exponent laws. The exponent on the 2 here is actually a 1, right, if they don't write it. Likewise, the exponent on the 5 is actually a 1. So what we have here is this power of 4 is being applied to both of these terms. So really, this is 2 to the 1 to the power of 4, a cubed to the power of 4. This will be 5 to the power of 1 to the power of 3, and then a squared to the power of 3. So all of these questions here are power to a power. When you have power to a power, you multiply. So this would be 2 to the 4. This would be a to the 12. This would be 5 to the 3rd, and this would be a to the 6th. Now, multiplication is commutative, and what that means is you can move things around in any order you wish. So in this case here, I can put the 2 to the 4th first, 5 to the 3rd second, putting the numbers together. Then I have a to the 12 times a to the 6. Well, now I'm multiplying with the same base, and in which case I add the exponents, and we would get a to the power of 18. Okay, let's look at the next one here. Again, this 4 is actually applied to both of these. This 3 is applied to the a to the power 1. Remember we talked about that the power on this a would be a 1. So now this becomes a to the power of 2 to the power of 4, b cubed to the power of 4, a to the power 1 cubed, b squared cubed, in which case here this is a to the power of 8 times b to the power of 12 over a to the power of 3 times b to the power of 6. Now you'll notice we've done our power to a power rule. Now I have an operation of division going on between these, right? Again, in math, you can write this as a to the power of 8 over a to the power of 3 times b to the power of 12 over b to the power of 6. You'll notice now I'm dividing with the same base, in which case I subtract the exponents. So 8 minus 3 is 5, and likewise, this will be b to the power of 6, because 12 minus 6 is 6. Okay, let's look at the next one here. So same idea, this 3 gets applied to the k, this 2 gets applied to the whole thing, the k plus 1. So what's going to happen here? Well, this is going to equal x to the 3k, right? K times 3 is k3 or 3k. Normally you put the number in front, so I write this as 3k. And now watch out here, this becomes x to the 2 times k plus 1. Now if you notice here, we're multiplying with the same base. You add the exponent, so this becomes 3k plus 2 times k plus 1. And again, you can clean this up a bit, right? I can distribute that 2, and then I can collect like terms. 3k plus 5k is 5k plus 2. Okay, quite a lot going on in this question, but we just tackle it piece by piece, and you'll see it's a lot easier than it looks. So if I were to tackle this problem, again, the operation between these is all division. So I can group these in an order that makes sense for me and makes the math easy. Well, I'm going to put the numbers together. I'm going to put the common bases of c together. And likewise, I'm going to put the common bases of d together. And I'm going to put a power 1 on that. Now, the operation between these two is multiplication. So I'll just keep going. This becomes 15 over 18. C over 3 times c to the 1 over c to the 1. And d to the power 9 divided by d to the power 5. So now that I'm here, I can go ahead and work through some of these operations. Well, 24 divided by negative 8 is negative 3. Here I'm dividing with the same base, so this becomes c to the power 6. This would be d to the power 4. Here in this next one, I can just simplify this fraction. I can't do much more. So I can divide top and bottom by 3, giving me 5 over 6. This will become c squared, and this will become d to the power 4. So let's look if there's any other simplification. Well, I can divide this by negative 3, giving me a 1. And I can divide this by negative 3, giving me a negative 2 here. I can also put these two together. So this will be, I'm multiplying at the same base. You add the exponents. This will be c to the power of 8. Likewise, I can put these together, giving me d to the power of 8. And now it's times 5 over negative 2. So to clean this up here, and like we've talked about, minus signs you push to the top, and normally you put the coefficients out in front. So rewriting this, you have negative 5 over 2, c to the 8 times d to the 8. Okay, this next question here says expressed as a power of 2. So what you got to do here is you got to think about, okay, well, how do I write 8 as a power of 2? Well, that's just going to be 2 cubed. How do I write 4 as a power of 2? Well, that's going to be 2 squared. So if they want me to write, if they want me to express this as powers of 2, I'm just going to replace that 8 with a 2 cubed. I'm going to put everything I don't touch back down. Likewise, I'll replace the 4 with a 2 squared, and everything I don't touch I write back down. Now we've got everything expressed as powers of 2. If you take a look here, power to a power, you multiply. So 3 times 3n is 2 to the 9n, and then 2 times 2n is 4n. Now I'm dividing with the same base. I subtract the exponents. So this would be 2 to the 9n minus 4n, which is 2 to the 5n. Okay, that concludes our video covering the 3 basic exponent laws. Please review these questions. Covers a lot of the exponent laws that we're dealing with here today. We did power to a power. We also did division rule, and then we also, in here is the multiplication. So study these through, go through them, and you'll see it comes down to 3 basic exponent laws. Multiplying with the same base, dividing with the same base, and then power to a power. Thank you.